This is our Algebra 2, Chapter 5 review activity. We're day 2. We're going to be focusing on factoring, quadratic formula, completing the square, graphing, imaginary numbers, complex numbers, and the discriminant in this. I'll try to move through this in a manner that which is hopefully clear. I'm just going to work through the problems one by one and talk your way through one by one. So this first section says solve by factoring. So as we're solving by factoring, as you know, we're going to need to set it all equal to 0. So I'm going to start by saying this 8x, and I'm going to bring the 15 over. I'm going to set that equal to 0. I'm now going to look at the signs. Because I have a negative at the back, I do know that my signs are going to have to be a plus and a minus as a possibility. And I'm now going to look at the factors of 12, 1 and 12, 2 and 6, 3 and 4. My factors of 15, 1 and 15, 3 and 5. Now historically, we do need to consider the fact that the numbers that are closest together typically work the best. And so I'm going to go with that as my first guess. And I'm going to work with 3 and 4. So 3x and 4x. Knowing that it's 3x and 4x, my number that goes in here cannot have a multiple of 3. So I cannot have a 3 there. I cannot have a 15 there. So those are both counted out of my left, or my choices over here on the right. So my only choice there really is going to be a 5 and a 3 at the back, or a 15 and a 1. But I'm going to try the 5 and a 3 first and see if those work. Now remember, I'm going to have a plus and a minus, so that's positive 20x. That's going to be a minus 9x, and you can see that's 11x, so that doesn't work. And so I'm going to have to try my other possibility there. My other possibility is going to be having 15 and 1. Once again, 15 cannot go here because the 3 and the 15 has a GCF. So I'm going to go with 1 and 15. That gets me 45x negative and 4x positive. Obviously that is not 8x, so I'm going to knock that out. Because I've tried both of these, that means that 3 and 4 are not going to be my factors on the front half. And so I'm going to have to then jump to the next possibility, which is trying 2x and 6x. Now, in the same way, what are my limitations here? In this spot where I have a 6 here, multiples of 3 and 2, I cannot have either the 3 or the 15 from my box up here. So what does that mean? We're going to have to try things other than 3 and 5 at the back. So we're going to try the 3 in the front and the 5 at the back, and I'm going to try it now. So I have 18x in the middle. I have minus 10x in the outsides. There's my 8x, and so I've got my factors: 2x plus 3, 6x minus 5, and now I'm going to set them each equal to 0. So 2x plus 3 equals 0, 6x minus 5 equals 0. So I solve that. 2x equals negative 3. 6x equals 5, so x equals negative 3 halves, x equals positive 5/6. I could write this in solution set notation. X is a member of the set of numbers, negative 3 halves, and 5/6. Okay, let's take a look at our second problem. Example 2. I've got 9x squared minus 25. I need to recognize that this is the difference of two squares. The difference of two squares factors into conjugates. That's a plus b and a minus b, just as a reminder. And so a plus b and a minus b are going to be exactly the same. So in this case, it's going to be 3x plus 5 and 3x minus 5. And so we set each of our factors equal to 0. And we're going to solve our problem. So 3x equals negative 5, x equals negative 5/3, 3x equals positive 5, x equals positive 5/3, so x is an element of the set of numbers negative 5/3 and positive 5/3. Let's move down to some more problems by factoring. Here I'm going to start by saying 2x squared minus x minus 28, and I'm going to have to ask myself first the question, is there a GCF in the problem? Since there's no GCF because the 2 doesn't go into the middle, I'm going to immediately look to my signs. And my signs are going to be plus and minus, 2x and 1x. Factors of 28 are 1 and 28, 2 and 14, 4, and 7. Because I have a 2 in the front, the numbers that cannot go there are 28, 2, 14, or 4, because they all would have a GCF in common with the 2. What does that mean? That means the only numbers that can go in the front are either the 7 and the 1. I'm going to try putting the 7 there, which means the 4 goes at the back, and I'm going to hope that that works. Let's see how that goes. We've got a 7x there and a negative 8x there. That's a negative 1x. That's what we want, negative 1x. And so we found it very quickly by using the idea of GCF elimination. So 2x plus 7 equals 0. X minus 4 equals 0. So 2x equals negative 7. X equals negative 7 halves. And x equals positive 4. So my answer is x is an element of the set of numbers negative 7 halves and positive 4. All right, moving on to example 4. We've got x cubed plus x squared minus 2x equals 0. Well, I'm going to look for a GCF. And in this case, the GCF does exist. It's an x. So I'm going to take that x out. X squared plus x minus 2 equals 0. I'm going to look to factor what's remaining because I have a minus sign at the back end. That means it's a plus and a minus. And I'm going to have an x and an x. What multiplies to 2 that adds to positive 1? That's positive 2 and negative 1. So because I have 3 factors, I set all 3 of my factors equal to 0. And I solve each one. And my answers are negative 2, 0, and 1. Notice I'm trying to put those in the order from least to greatest on the number line. So those are my 3 answers. X is an element of the set of numbers negative 2, 0, and 1. This next little section is going to be doing completing the square and solving problems with completing the square. When we're completing the square, we need to approach the problem and get rid of the constant by moving it to the other side and instead putting in a blank in the problem. Now I'm going to think to myself, what is half of 6? And that's negative 3. And so then I have that negative 3 squared, and I have to say to myself, what is negative 3 squared? It's 9. So to balance the problem, I'm going to add 9 to the other side as well. What does that give me? Moving on, that gives me negative 11. I'm not worried about that negative 11 because I'm going to take the square root of both sides. And when I take the square root of a negative, we are going to have to consider the fact that we've got plus or minus there because we took 2 square roots. When we take the square root to the left, we get x minus 3 coming out. The negative comes out as an I, and we're left with the square root of 11 on the inside. So we bring the 3 over, and we have 3 plus or minus I squared 11. You don't need to write this as 2 different parts. You can leave that with the plus or minus. Perfectly fine right now. I'm not going to write that one with element notation, but we can just leave our answer as such. Let's look at example 6. We already have the constant on the other side, so I'm going to put in the blanks and work it from here. Thinking through, half of 10x is 5, and so that's going to be x plus 5 squared. And then I'm going to have to say, okay, half of 10 is 5, 5 squared is 25, and so I'm going to add a 25 to both sides, giving me on the right-hand side a value of 36. Now I'm going to take the square root of the left, x plus 5 squared. I'm going to take the square root of the right. Notice I immediately put a plus or minus in. So I've got x plus 5 equals plus or minus 6. Now I'm going to solve this and get x plus 5 equals 6, or x plus 5 equals negative 6. I'm going to subtract 5 from both sides, so x equals 1, x equals negative 11, and so my answer is x as an element of the set of numbers negative 11 and 1. Let's move down to completing the square, this time when we have odd numbers in the b term. The b term being the middle term, the linear term. Once a reminder, this is the quadratic term, the linear term, and the constant. So here we've got a 5x in the middle, so I'm going to think half of 5 is 5 halves. Okay, half of 5 is 5 halves. 5 halves squared is going to be added to both sides. And 5 halves squared is 25 fourths. So I add 25 fourths to both sides. Now 24 fourths plus 25 fourths is 49 fourths. I'm now going to take the square root of both sides, putting that plus or minus out front, giving me x plus 5 halves equals plus or minus 7 halves. So I have x plus 5 halves equals 7 halves, or x plus 5 halves equals negative 7 halves. So x equals negative 5 halves plus 7 halves, which is 2 halves, which is 1, or x equals negative 5 halves minus 7 halves, which is negative 12 halves, which is negative 6. So in this case it worked out very nicely. X is an element of the set of numbers negative 6 and positive 1. Example 8. Here we have a b term of 1x. And so we're going to have half of the 1 and then square that and add it to both sides. So half of 1 obviously is 1/2. So we're going to square that and add it to both sides. So I'm going to add a quarter to both sides. I need to change this 5 halves into quarters. So that's going to be 10 fourths plus 1/4. Now I'm going to take the square root of both sides. So when I take the square root of both sides, I'm going to get x plus minus 1/2 on the one side, and the square root of negative 9 fourths on the other side, and don't forget your plus or minus. So you get x minus 1/2 equals plus or minus 3i over 2. I'm going to bring the 1/2 over and say 1/2 plus or minus 3i over 2. Some books are going to write this with the numerators combined. Either one of these bottom two solutions is correct. It doesn't matter which one you're going to go with. Next, we're going to do some problems by graphing. In our graphing, we're going to focus on trying to find first the vertex, the axis of symmetry, the y-intercept, and then we're going to see if the pattern based on the a value matches up with the y-intercept. And if that happens, that's going to be our check. So let's look down here at example 9. My value of a is 1, my b is negative 6, and my c is 4. So remembering that the axis of symmetry is the opposite of b over 2a. We're going to go about that and we're going to find that value. So we have the opposite of 6, so the opposite of negative 6 all over 2 times 1. So that's 6 over 2, so x equals 3. So I'm going to put a dotted line at x equals 3. That's my axis of symmetry, just for the problem. Now we're going to take that value of x equals 3, and we're going to plug it in to x squared minus 6x plus 4 equals 0. And we're going to see what we can find out what the value of this is. So that is 9 minus 6 times 3 plus 4. That's 9 minus 18 plus 4. That's negative 9 plus 4. That's negative 5. So the vertex of this parabola is at 3, negative 5. So I'm going to go down to negative 5 and put a red dot there. 1, 2, 3, 4, 5. There's my red dot. There's my vertex. Now I'm going to look at the value of a. Since a equals 1, the pattern of our problem is going to be over 1, up 1, over 2, up 4, over 3, up 9. So I'm going to very carefully try to graph this using green points. Over 1, up 1, over 2, up 4, and now over 3, up 9. So there's 5, 6, 7, 8, 9. So I've got my points, and I'm going to sketch this coming down, curving at the bottom, and coming up. The problem is asking us to estimate where this crosses the x-axis. And so estimating where this crosses the x-axis, I know it's going to cross between 0 and 1. And so my best guess is right about there and there. It looks like it's closer to the 1 and closer to the 5. So here's 1, there's 5, here's our axis of symmetry at 3. So I'm going to say it's somewhere like 5 1/4 and 0.75. So my best estimate here for my answer is going to be x equals 0.75, comma 0, and x equals 5 1/4, comma 0. Now I don't know exactly what the answers are, but that's my best guess based on my estimate there. What is my y-intercept? My y-intercept is up here at 4, 0, comma 4. And now we're going to compare, and we're going to say, you know what? Does that y-intercept match up with the value of c? If it does, then our pattern matched up and our vertex is correct. So there's just a quick sketch using the idea of axis of symmetry, y-intercept, patterns, and plugging in numbers to find the vertex. Let's try this one more time with a different problem. Here we have 2x squared plus 4x minus 1. So we've got 2, 4, and negative 1. Remember, your axis of symmetry is the opposite of b over 2a. So in this case, we have the opposite of 4 over 2 times 2. That's negative 4 over 4. So x equals negative 1. Let's plug that value in to find the value for our vertex when we're graphing. 2 times 1 minus 4 minus 1. That's 2 minus 4, negative 2. So it looks like our vertex is at the point negative 1, comma negative 3. So I'm going to sketch the value of negative 1 for my axis of symmetry. And once again, I'm going to put a red dot down at my vertex at negative 3. The pattern on this problem has an a value of 2. So instead of going 1, 1, we're going to go 1, 2, because you're going to multiply by a. So over 1 and up 2. And then instead of going the pattern 2, 4, we're going to go over 2 and up 8. 2 times 4 is 8. So over 2 and up 8. And that's all we're going to get on this graph, really. So we're going to sketch once again. And we're going to make our best estimates here. And so I'm going to zoom in once again, and I'm going to try to make my best estimates here. Right about there and there. I'm going to think it's about 0.3 and about 2.3 on the negative side. So my best estimate, positive 0.3, comma 0, and negative 2.3, comma 0. I don't know if those are plus or minus a half or so, but I would say they're fairly close. They're obviously between 0 and 1, and between negative 2 and negative 3. What's my y-intercept from looking at my graph? My y-intercept is right here at negative 1. So that's the value 0, comma, negative 1. And then let's zoom back out and let's look back up. Does that value match up with our c value? Indeed it does, which means we've graphed it correctly and we've got a good job there. So let's slide down now and jump to the quadratic formula. Remembering the quadratic formula, we're going to write it up here at the top. And remember, it's x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Now, my only request is that you don't sing that during the test because it might be disturbing to others. So let's start off and use the quadratic formula to solve this problem. We've got a equals 4, b equals negative 8, and c equals positive 3. That means x equals the opposite of negative 8 plus or minus the square root of negative 8 squared, put that in parentheses, minus 4 times 4 times 3, all over 2 times 4. That's the biggest step in your problem. So you've got 8 plus or minus the square root of 64. Now, 4 times 4 is 16. 16 times 3 is 48. So I've got 64 minus 48 all over 8. Just as a side note, there will not be any calculators used on the test. So you're going to have to do this basic computation using scratch paper. The square root of 16 is 4, and so I've got 8 plus 4 over 8, and I've got 8 minus 4 over 8. So 8 plus 4 is 12/8. 8 minus 4 is 4/8. And so it looks like my answers are 3/2 or 1/2. Let's look at this one. A equals 3, B equals -6, C equals 4, X equals the opposite of -6, plus or minus the square root of -6 squared minus 4 times A times C all over 2A. So X equals 6 plus or minus 36. 4 times 3 is 12. 12 times 4 is 48. So I've got minus 48 all over 6. 36 minus 48 is -12. Square root all over 6. So the negative comes out as an I. The 12 breaks down to a 4 and a 3 all over 6. So that's 2I squared of 3 over 6. Now, special case scenario. These three numbers are all divisible by 2, which gives me a final answer dividing all of those of 2 by 3 plus or minus I root 3 all over 3. Okay, so there's two examples of the quadratic formula. One gives you an I, one giving you fractions. Both are very possible. Just want to make sure that we're comfortable with those. Let's now do some simplifying using imaginary numbers. Remember that I equals the square root of -1. So if you have a negative inside a square root, it's just going to come out as an I, so I root 10. Once again, the I comes out, but the 24 breaks down into 4 and 6. 4 is the largest perfect square that goes into 24. So I times 2 square root of 6, but we're going to write this as 2I square root of 6 is really a more common acceptable way. The I comes out, and that leaves us with the square root of 100. But the square root of 100 is 10, and so we have 10I. The square root of 28 is going to break down into 4 and 7. The square root of 4 is 2, so we have 2I squared to 7. Down here, we have to consider if I equals the square root of -1, then I squared equals -1. So this is really -1 minus 5, or -6. Coming over to example 18, we're multiplying. 8 times -5 is -40. I times I is I squared. But remember, I squared is -1. So we have positive 40. So there's just a couple problems involving using i's and imaginary numbers and simplifying as low as we possibly can. All of these would be referred to as imaginary numbers and complex numbers. None of them need to be written in the form a plus bi because we don't have an a term. Let's go down here now and look at adding and subtracting. On example 19, we're supposed to add them together. So we're going to combine the 3 and the 5 and get 8. We're going to combine the 2i and the -I and get plus I. And so that's our answer, 8 plus I. And that's written as a complex number. You're not going to say 8 plus 1i, but just 8 plus I. Example 20 is a little bit more dicey. You have to pay attention to distributing the negative sign. So we do that, and that becomes a plus 8i at the back end. And now we're just going to combine our like terms. We have 4 minus 6 is -2. Then we have -1i and positive 8i. That gets us 7i. And so a plus bi form -2 plus 7i. Let's look down here at example 21 and let's FOIL. First is 2 times 4, which is 8. Outside, 2 times -I is -2i. Inside is positive 20i. And then last is minus 5i squared. The important thing on this problem is to recognize at the back that 5i squared is really -5 times -1, which is positive 5. And when you add that to the 8, you're going to get 13 plus 18i. Our last one with our imaginary numbers is FOILing. These are conjugates. Conjugates are numbers like a plus b and a minus b. So 10 times 10 is 100. Outside, we have positive 10i. Inside, negative 10i. And then we have minus I squared. What's unique about the conjugates is they cancel out, leaving us with 100 minus I squared. But remember that I squared is really -1. And so we have 100 plus 1, or 101 as our final answer. The last part we're going to look at is using the discriminant to classify solutions. The discriminant is the inside square root portion of the quadratic formula. It's the b squared minus 4ac. If b squared minus 4ac is less than 0, you'll get two imaginary numbers. If b squared minus 4ac is equal to 0, you'll get one real number. And if b squared minus 4ac is greater than 0, you'll get real numbers. So we're going to answer, is it less than 0, is it greater than 0, or is it equal to 0? And based on those three different possibilities will be what kind of answers we have. So here, a equals 3, b equals -1, c equals 5. So -1 squared minus 4 times 3 times 5. Well, that's 1 minus 60. That's obviously negative. And because it's a negative number, we're going to have two imaginary solutions. Over here, we have a equals 10, b equals -6, c equals -5. So -6 squared minus 4 times 10 times -5. Well, that's 36 plus 4 times 10 is 40 times 5 is 200. And because we have two negatives, that's going to be a positive. Because it's a positive number, we're going to still get two solutions, but these are going to be real solutions. Down on example 25, a is 3, b is -2, c is 0. It's unknown. So -2 squared minus 4 times 3 times 0, well, that's just going to be 4, which is a positive number. So we have two real solutions. Example 26, a is 8, b is 0, and c is +2. So we have 0 squared minus 4 times 8 times 2. Well, that's going to be -64, which is a negative number. And since you're taking the square root of a negative number, you're going to have two imaginary answers. Now, in none of these cases that we did on these four examples did we end up getting b squared minus 4ac equal to 0. Just as a reminder, if b squared minus 4ac is equal to 0, the result to that is you have one real answer. All right, I hope this helps in terms of understanding what we've been doing. We're going to stop the recording here and go from there.